All right, welcome to our first video in our series for the Civil PE exam, where we are going to start with load and load applications. So in this problem, we're presented with the following statement. A lag screw connection is shown in the figure. The tensile force in pounds in the top lag screw is most nearly 582, 619, 800, or 2,400. So what we have here is a joist that is connected to a ledger board that is 3 inches wide, and that ledger is then connected to a wall with lag screws. And the joist has a reaction of 1.6 kips at the end of it, and the resultant compression force acts at a distance of a half an inch above the bottom of this ledger board. So the first step in this problem is to figure out the applied moment, right? So we're going to solve for the moment, and the moment is going to be equal to this force of 1.6 kips times the distance away from the wall that it acts, which is 3 inches. So the moment, and we're going to solve for this in pounds because the question is looking for it in pounds. So the moment is equal to 1.6 kips. We'll convert that to pounds times 1,000 pounds per kip times 3 inches is equal to, and we'll plug that into our calculator, and we'll get 4,800 pounds. Or 4.8 kip inches, right? So that is a moment. So the next step is to figure out how this moment is resolved. And we know that the way that in this problem the moment is resolved is by a tension force and a compression force from our screws, right? So if we were to draw this out, we have at the top screw tension, and then at the bottom we have compression, right? And so what we want to do is figure out what that distance is. We'll call that the lever arm here, right? And so that lever arm is going to be equal to, so what is that distance, right? It's going to be where this compression force acts, and then where the tension force acts, right? The distance between where the tension acts and where the compression acts. Well, the tension acts 8.25 inches above the bottom of the joist. The compression acts a half an inch above the joist. So that distance is going to be equal to 8.25 minus 0.5 is equal to 7.75 inches, okay? So how do we get the tension, right? Well, we know that the tension is equal to this moment force divided by that lever arm, right? So that tension is going to be equal to 4,800 inches divided by 7.75. and that is equal to 619.35 pounds. And that is most nearly choice B.